Okay, question 19. John can paint the room in 4 hours. That means his speed is 1 room in 4 hours. Jack can paint in the room in 5 hours, so that's 1 room in 5 hours. If John starts to work alone at 1 p.m. until 2, so John works for an hour. That's the guy that can work 1/4 of his speed is 1 room in 4 hours. And then they both work together. So X represents the amount of time that they work together. But John worked X plus 1 hours, and Jack only worked X hours. And together, so this is the amount of work that John has done. Remember, it's rate times time. That's how much work he's gotten done. And rate times time is how much work Jack has gotten done. Together, they're going to paint 1 room. Okay? So you can see that I distributed 1/4, and I brought this 1/4 to the other side and made it 3/4. And then I added the 1/4 and the 1/5. But to be truthful, you can get rid of them by multiplying by 20. But I changed them to have a common denominator of 20 and added them together, and that was 9/20. And so to get rid of 9/20, I multiplied by the reciprocal, which is 20/9. And when you take 3/4 and you multiply by 20/9, you get 5/3. Now, keep in mind, 5/3 is the amount of time. That's an hour and 40 minutes, right? That's 1 2/3 hours. That amount of time plus the hour that it says, when will they finish the room? So I'm just trying to figure out. So if I take, so let's see here, 2 2/3 hours from when John started, and John started at 1. Or you could just take 1 2/3 hours and add it to the 2 p.m. time slot. Either way, whether you start at 1 o'clock and add 2 hours and 40 minutes, or whether you start at 2 o'clock and add 1 hour and 40 minutes, they still get done at 3 hours and 40 minutes, okay, or 3:40 in the afternoon. Okay, choice C. The line segment, question 20. The line segment AB has coordinates -1, 3 and 5, 7. Find the equation of its perpendicular bisector. Well, 2 things. I need the slope of the line. Okay, so I found the slope of this line, right? Difference in the y's over difference in the x's, and got 2/3. I want the opposite reciprocal because we're talking about something that's perpendicular. Being a bisector, it also has to go through the midpoint of the line segment, so I actually needed to find the midpoint of these 2 coordinates, right? Average x, average y, and that was coordinates 2, 5. So I have this slope and I have this point, and I can use my point slope form and change it into slope intercept. I hope you can follow my logic there. Distributing the -3/2 and adding the 5, I ended up with -3/2 x plus 8, which is choice A. Okay, question 21. For x between 0 and 2 pi, find the solutions to this equation. Keep in mind that, so I inverted the sign, right? The inverse sign of -2/2, if you think about the unit, whoa, not much of a unit circle, is it? Looks more like a unit egg. -2/2 for the y values, so there's -1/2, we're talking -2/2, we're here and we're here. Okay, so these 2 spots on the unit circle, so that would be 5 pi over 4 is one of them, and if you do the other one, that would be 7 pi over 4. Now keep in mind those are both equal to 2x, and so you would actually need to divide by 2 or multiply by 1/2 to find 5 pi over 8 and 7 pi over 8. Now, the interesting thing is, so those are 2 of the answers, 5 pi over 8 and 7 pi over 8. So, you can get rid of some of the choices there. Well, interestingly enough, you can get rid of all the choices except for the first one, because this one's got 5 pi over 8 in it, but it doesn't have 7 pi over 8. Wow, that made that work pretty easy. But if you didn't know this, the period of the function has been pi because it's been reduced. For those of you that don't know, 2x over 1 is the same thing as x over 1/2, and so it has been shrunk. So the old period of 2 pi for a sine wave had been reduced by 1/2 to 1 pi. And so in other words, I could take these two answers and add pi to them. And if I take pi and add it to that, that'd be 8 pi over 8 plus 5 pi over 8 would be 13 pi over 8. And if I add 8 pi over 8 to this one, I'm going to get 15 pi over 8. So that's why the other two answers are there. Still within inside of the period of 2 pi. Question 22, find the value of x given this information. So, as you can see, I changed 25 to 5 squared, and I know that when you are dividing like bases, you can subtract the exponent. So I have 2 minus this exponent, which is distributed the negative, and I got 2 minus 3x minus 8. Okay, just following my logic there. That would be 2 minus 8 would be negative 6. So I have negative 6 minus 3x. Keep in mind, here's what we started with on the left side of the equation, and we're simplifying the right side, and we get all the way over to here. So those exponents have to be the same. So negative 6 minus 3x has to be the same thing as 1 minus x. So I wrote the exponents together and started solving until I got 3.5, negative 3.5, which is the same thing as negative 7 over 2. Choice A. 23. 23. Cosine of x over 2 is less than or equal to 1/2. Well, if you think about this, the cosine function looks like this. X over 2 means that it has been stretched by, the period has been stretched all the way to 4 pi. Right? It's been doubled from 2 pi to 4 pi. And so if you want to know when that's less than 1/2, oh yeah, this is the one that I had to think a little bit more about. First thing I did was I inverted the cosine of 1/2, and I ended up with pi over 3 based upon what we know about the unit circle, right? When x is 1/2, we're talking about an angle measurement at pi over 3. And that's equal to x over 2. So what I did was I took that and I multiplied by 2 and to change this into 2 pi over 3. So I knew that would be the first place that it would happen, and then everywhere in between all the way up to 2 pi would be less than 1/2. So anyway, I can't remember what I was thinking about this particular question. Yeah, I'm pretty sure I checked the answer sheet, but let me double check the answer sheet. 23 is B. Yep. So I'm going to have to think about that graph just a little bit more. But I definitely know this logic could be used because of that stretching to 4 pi. I guess maybe I should think about it on a normal cosine wave and then just stretch it. That probably would be the case. Okay, 24. The area of a 12-sided regular polygon is inscribed in a circle of radius 8. Okay, so basically what I did was I took my 12-sided polygon and I cut out one of the pieces. There's 12 of them, all connected at the central location of the polygon, which would also be the center of the circle. The center of the circle has a radius of 8. Therefore, that's the same length as the radius of the triangles, which makes this an isosceles triangle, all that good stuff. What we don't know is the base, that part of the base. One trick you need to know is that all the exterior, all these, well, if you think about it, all of these 12 different angles in here add up to 360. So I took 360 and divided by 12, and I found out that the top part of this triangle is 30. Well, if you cut that in half, you get 15. So I have a right triangle with a 15-degree angle at the top and a, what is that, 65-degree angle there at the bottom. I guess what I started doing was figuring out all this stuff, thinking that I needed to find this bottom side of the triangle, and then it dawned on me. It's the half absence formula. Okay, 1/2 AB sine C, which is basically half the product of the two sides and the angle in between. Well, clearly we have the two sides and the angle 30 degrees in between. Now, if you can tell me what the triangle, the area of this triangle is, well, guess what? I'm just going to multiply it by 12, because I got 12 of these things inside of this 12-sided regular polygon. So that's what I did. I did 1/2 AB. A and B are both the same, sine of 30. We know that the sine of 30 degrees is 1/2. So we were able to calculate that this triangle had an area of 16, and of course then I just multiplied by 12 because I have 12 triangles, and I got 192. Okay, question 25. Angle of depression is measured from the horizontal down, and it says that it's 40 degrees. And the height is 280. A tower is 280 feet tall. From its top angle of depression, find the approximate distance in feet from the base. Okay, so that's the side length up here called x. So what I did was this. I said, I took the tangent, right? Opposite over adjacent. Tangent of 40 is opposite over adjacent, and I cross multiplied. And when I cross multiplied, I got 333.69, which is closest to 334. Choice D. I actually had to go to the website, or to I didn't even, something malfunctioned when it was printing, so I didn't even have the right question. The question is actually, which of the following is an expression for sine of 5x, but I didn't even have that because so I didn't know what it was. So I was looking for something that's either equal to sine 2x plus 3x or sine x plus 4x. Those were my two choices, really. And then I looked, I needed to know this fact. Sine of x plus y is equal to sine x cosine y plus cosine x sine y. Knowing that fact right there, I was able to easily come up with the correct answer, which is choice E. So if you actually look at the practice test, you'll find this choice right here, and it's the same sign plus in the middle that you see inside of here, plus. The area of the triangle is question 27. The area of the triangle is 32, and side AB's 8, AC's 13. Here's what I ended up doing. I used the half absence formula, but this time I knew 32 was over there, and I was able to start solving. 1/2 8 times 13 is 52, so I divided by 52 and inverted the sign, and I ended up with a 38-degree angle. Once again, if you actually go to the correct practice test, you'll see this is the correct question to start with, and then they said which one of these is the same as this. So I started out with that. I replaced tangent x with sine x over cosine x, and I replaced secant x with 1 over cosine x. I decided to multiply the top and the bottom by cosine x, and I could leave these two on the top alone, and on the bottom, when I multiplied this one times that one, the cosines canceled, leaving me sine x, and when I multiplied that one times this one, I got plus 1. Of course, the sine x plus 1 canceled, leaving me just plain old cosine x. And that's choice, obviously choice B. Didn't show up on my sheet very well at all. Okay, yes, this very, very ugly looking thing. So here's the work. Okay, so I've got log base A of x is equal to 4, log base A of the square root of y equals -1, and log base A of z squared equals 3. Find log base A of z squared y cubed over c to the 5th. So here's the work. I simplified, I changed them from their log forms to their exponential forms. So log form to exponential form, right? A to the fourth. All I'm doing is the swoosh thing, if you know what I'm talking about. A to the fourth equals x. A to the negative 1 equals the square root of y, and then I solve that for by raising both sides to the second power and getting y by itself. So that'd be a to the negative second y equals y. And then the last one, a to the third equals z squared. And so I raise both sides to the 1/2 power, giving me z equals a to the 3/2 power. Then I could substitute x, y, and z into the expression that they wanted me to find. And when I did that, and then I started, well, 4 times 2 is 8, negative 2 times 3 is negative 6, got those two values. 3/2 times 5, that's 1.5 times 5, isn't it? 7.5. And then we know we add the like terms, or when we are multiplying like bases, we add the exponents, and then, so that'd be positive 2 on top. But when you divide like bases, you subtract the exponents. That's where we got negative 5.5. Okay. And this, when you're looking for the answer here, it's what's the exponent on a, which gets me a to the negative 5.5. Well, since these two are written and they have the same base, the answer is negative 5.5, which happens to be negative 11 over 2, or choice E. Some of the minus signs kind of got eliminated from the answer choices when I printed mine off. Don't ask me how. It's kind of weird. Question 30. I've got tangent x equals negative 2, tangent y equals 3. Find the value of tan y minus x. And I used this particular property, substituted in all the values, and solved, and I got negative 1. That was a pretty straightforward question. 31, the line segment AB with coordinates negative 2, 8, negative 4, 6 is the diameter of a circle. Find the center and radius of the circle. So center would be the midpoint of the line segment. So average x, average y. So I average the x's and the y's. And I got negative 3.7. And then found the distance from that to the edge of the circle. Negative 3 and negative 4 are 1 unit away from each other. 6 and 7 are 1 unit away from each other. The little Pythagorean theorem tells me that the radius is radical 2. In the triangle length, AC is 4, AB is 9, BC is 7, so I labeled the sides, right? Find the approximate value of angle C in degrees. Well, it's not a right triangle, and so I can't use any SOHCAHTOA, sine, cosine, or tangent. It does not have a known angle and a known opposite side, so I cannot use the law of sines. I'm forced to use the law of cosines. The angle that I'm looking for is angle C. It is opposite side 9, so when I write my equation, these are the first two things that I put in my equation, the C on the right and the 9 on the left. So we have 9 squared equals, and then I need 4 and a 7 and a 4 and a 7 put into places for the other sides. 4 squared plus 7 squared is, 65? And you want to subtract that to the other side to get 16. Negative 2 times 4 times 7 is negative 56. Then I'm going to divide that to the other side. When I invert the cosine, I end up with 107 degrees. Okay, so this expression is equivalent to which of the following? So 2 tan x is divided by secant squared x. I wrote it out horizontally, and then I changed tangent x to sine x over cosine x. And secant squared, it changed it from dividing by that to multiplying by the reciprocal. And the reciprocal, obviously, of secant is cosine. Well, so one of the cosines is going to get eliminated, and that's 2 sine x cosine x. But we know that better as sine 2x. That's one of your properties of in your trig identities. So look up trig identities. Obviously, you've seen a few of them in this practice test. Don't even ask me what question 34 is about, because they use the function f of x twice, and I can't tell you what I mean, if they meant for something to be written differently, f of x and g of x or something like that, they have not been clear enough. So I don't even know how to answer question 34 because I don't even understand the question. Something got misprinted. I know it. I must have. 35. Which of the following is equal to that? Well, this is a quadratic. And the nasty, ugly part about this quadratic is that the coefficients a, b, and c, two of them, a and c, are both complex numbers. So I use the quadratic formula. All right. So here's my work on the quadratic formula. If you want to take a look at it, you know, the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So you've got to do some distributing, some FOILing. Keep in mind that I squared is equal to negative 1, so negative I squared is positive 1. And then I went through the process of solving. You can take a look at my work. Square root of negative 16 is 4i. I did have to, I took a 2 out of all of this stuff. That gave me 1 plus or minus 2i all over 2 minus i. And then I foiled the top, foiled the bottom kind of thing. 4, those cancel out because they're conjugates. You'd have a 2i and a negative 2i, and then negative I squared. So that's going to be plus 1. So 5 on the bottom, and we end up with 4 minus 3i on the top. So there's my answer. Question, or part D. This practice test should be online. I don't know if you need the answers for these. You can take a look at them. I think we've gone through them enough. But there are those answers for you. Okay, good luck on the test. We'll see you as practices continue.